right. Cool. Hello, everyone, and welcome back to another episode of PyTorch Community Voices. So good to see you all again on this Wednesday, wherever you are in the world. So today we have a really interesting guest, Sergey from Catalyst. And so for those in the audience who may not have used Catalyst before, so just some background on the project that we'll be talking about. So Catalyst at a high level is a PyTorch framework that allows users to write, compact but really full-featured deep learning and reinforcement learning pipelines in just a few lines of code. And you might be wondering, like, why is this important? We have PyTorch. Well, so you can think of it as what we have at small scales. If you write training loops at small scales, it's simple. But then once the size of the project grows, this series of loops can get just large and complicated. So what Catalyst does is it creates this abstraction layer that taps into that underlying PyTorch code and allows users to leverage that underlying code, but in a cleaner, high-level deep learning API framework, and that's Catalyst. Actually, sorry, I realized I jumped in before doing introductions, I guess to just have this project in front of mind. So for those of you watching, I am Jessica. I am one of the Facebook developer advocates focused on our AI and ML open source projects. And so, as I said before, we'll be talking with Sergey about his project Catalyst. And so, let me just pull him up and we can get to actually meet him. So let's add Sergey to the screen.
Hi guys, nice to meet you. Yeah, so I was somehow already introduced. My name is Sergey. 3 years ago, I thought that it would be quite easy to develop some high-level API on top of PyTorch. Long story short, no. And
go ahead.
And now I'm here. So I don't know. Maybe it's a default introduction because I have another one during the talk.
Okay. Well, I guess maybe we'll save it for then as well. So for those of you watching the show for the first time, so the format of it goes, Sergey will do a presentation about Catalyst, as he's alluding to, and he'll give an overview and a little dive and demo of the project. And throughout it, we highly recommend that you post your questions in the chat. So Sergey is here to answer your questions live, so please take advantage of that. And yeah, I guess with that, we'll ask us, are you ready to start off the conversation with the presentation?
Yeah, quite easy. By the way, if you have any questions, we have our community and our Slack community. So we are, quite open one. So it's quite easy to ask the questions. So let me share the screen correctly.
Okay.
Let's check it out.
All right, I'm gonna pull it up.
Yep, looks like everything works correctly. A few lines of code, So
I'll step back and let you go.
Yeah, let's start, guys. Hello, my name is Sergey Kolesnikov, as you were already told. I'm head of research at Tinkoff Center. But what is more important today, I'm also the creator of the Catalyst, which is a high-level framework on top of PyTorch for both deep learning and reinforcement learning R&D. And today, I would like to talk a little bit about the Catalyst. Why do we need it? When should you use it? And introduce a few examples of different use cases solved with the Catalyst framework. But before we start, a small recap of the PyTorch. I think all of you know what PyTorch is and how it is great. It has its low-level API, which is easy to use, which is purely Pythonic, and great for both research and production use cases. On the left part of the slide, you can see an example of the PyTorch pipeline. So you can see that it's quite easy to create your data, create your model, optimizer, scheduler, and write this simple, functional-oriented, maybe we can say so, deep learning pipeline for both train and validation phases. So everything looks easy to follow, and you could ask, why should we want anything more, or what else do we need? So in my opinion, I have done a large variety of different PyTorch-based projects. There are a few things that could boost your productivity as a researcher and both as a developer. First of all, it's universal pipeline execution. On the previous slide, you could see that we have very common steps for both training and validation phases of your model. Second part, which I'm very triggered by, is reproducibility, because we have a large number of domains like healthcare, or for example, financial industry, where reproducibility really matters when you do your deep learning decisions. Last but not least, it would be also great to have this framework, if we are developing it, with multi-stage pipeline support to run these complex experiments, like, for example, network fine-tuning for your tasks, with these multiple stages on fine-tuning the head only and tuning the whole network in one single run. Because between the stages is usually some kind of bugs, so it's easier to get to the framework and automate this thing. Moreover, thanks to the rapid hardware accelerators growth, it would be great to have a simple API for distributed and mixed precision training within the framework. Last but not least, if we are speaking about generalization, it would be also great to have this common metrics for different tasks like classification, segmentation, natural language processing, recommender system, and so on, implemented and tested. And moreover, if we are speaking about reproducibility, which our second statement, it would be great to have a native config support to store all your hyperparameters for full reproducibility. And as far as we are developing a framework on top of the framework, there should be an easy to use way for pipeline customization, because PyTorch is still great. For example, in the catalyst, we have a callback mechanism for this customization. Nevertheless, how we could get all of this, how to develop this framework to meet all these requirements? The answer, of course, is very simple and straightforward. Just use the catalyst, right? Because long story short, catalyst is this PyTorch framework for deep learning research and development, which focuses on reproducibility, rapid experimentation, and code-based reuse. So you could create something new rather than write this yet another train loop, which I'm not very fond of. I'm really fond of the PyTorch bus, but the amount of code is a little bit heavy with large projects. So, and to showcase how all this working in the catalyst, let's discuss some examples and to see the difference with the PyTorch, or if we could find them, of course. So, on the slide, you can see a pure PyTorch pipeline on the left and Catalyst 1 on the right. As I already said, Catalyst is a high-level framework with all low-level configuration freedom. In such a case, Catalyst could be used as a simple for-loop wrapper for the PyTorch. By that, I mean that the only thing that you really have to specify is your batch handling logic of your pipeline. I hope you see my mouse, so I try to identify this slide area. And as you can see, we have the same code for both PyTorch and Catalyst pipelines, like for data creation, components creation, like model optimizer, etc., and train and validation phases, the same, except that Catalyst 1 is a little bit shorter and have such easier-friendly tools, like, for example, from Catalyst import metrics. All other parts, like model forward, backward pass, like metrics computations, like their logging, are the same and could be done natively with the PyTorch code. So these examples showcase you that it's quite easy to integrate Catalyst with the PyTorch. But maybe you could already understand that as far as we could do such things, maybe we could make them even more user-friendly, because in this case, we are solving simple supervised learning tasks. Maybe we could make another abstraction to solve them quicker. And here we come to the Catalyst Python API. The pipeline example shown on the right. As you can see, we have an API for unified model training, evaluation, and inference. And what is essential, we do not introduce any PyTorch models mixins and do not rewrite any PyTorch internal primitives. Thus, all Catalyst abstractions are mostly PyTorch independent and could be reused with other framework if you are interested in such a thing. And within this API, we also introduce a variety of standard tools like different metrics computation, loggers, post-processing utils in the bottom, and simple API for the distributed training, which I will talk a little bit later. But what is more important, it's only the beginning of the Catalyst API. As a framework, we also support our advanced config API, which ensures full reproducibility and hyperparameters management. On the slide, you could see that we could define natively with YAML support. First of all, our tasks, for example, supervisor, to use our supervised runner for supervised tasks. Our custom network, for example, my custom net. Our hardware accelerator with this distributed data parallel MP engine. All our required metrics, in this case on the TensorBoard 1, but still all, and we could easily define all stages of our experiment where we can redefine and configure our used datasets and other components such as criterions optimizer, callbacks for each stage separately. And yes, our config API natively supports these complex multi-stage runs. But what is even greater, our config API supports hyperparameter tuning through the Aptuna framework. So you could run your hyperparameter search with complete code and config backups natively within one framework. Speaking of the Aptuna and the integrations, Catalyst has a wide variety of them. First of all, we have engines to support different hardware accelerator setups like PyTorch MP, NVIDIA Apex, Microsoft DeepSpeed, Facebook Fairscale, and of course, Google TPU. We also support different loggers for most common monitoring systems and metrics for different tasks like classification, segmentation, recommender systems, and so on. Thanks to our user-friendly callback mechanisms for different learning tricks, we also support batch overfitting, overstopping, and learning rate finder. And within these callbacks, we also support integrations with other frameworks, such as augmentations. I think you're familiar with this framework here if you're working with computer vision problems. Hydra, Corne, and Optuma, of course. By the way, it's only the part of our API, so if you're interested in a full description, please follow our documentation. The link is on the slide. And speaking of all these integrations, I would like to acknowledge all our community, which is really great. So thanks all of you. And with each help, we have additional build such packages like Alchemy, Catalyst Code Style, Hydra Slayer, and Reaction. All Catalyst Code Catalyst-based projects you can find on the bottom link, so give them a try. There are a number of interesting deep learning applications and papers implemented. And before we start our demos, which I think you're waiting for, two more important things. First of all, our team also have a collaboration with the Trend Center on deep learning applications for neuroimaging and brain analysis. And as a part of this collaboration, we are working on the NeuroCatalyst project. So if you're interested in this topic, please drop me a message after the call. And moreover, yeah, we also have a deep learning course, deep learning with the Catalyst course, which is focused on advanced deep learning techniques of recent years. For example, like deep dive into metric learning, or maybe text augmentation for the natural language processing, or reinforcement learning applications in the recommender systems. So if you are interested in such advanced stuff, join. It's fully open source and free to learn. And my favorite, of course, is the last one with the deep learning, deep reinforcement learning applications for the recommender system, which I'm really, which I find very inspiring. So, as far as we're talking about the course, let's try a few demos to showcase how the Catalyst feels like. The demos would be a little bit fast and furious because of the limited time, but I hope we could run them all. So, yeah, let's start from the simple demo, Catalyst GPU, that showcase how we could utilize, I don't know, the Catalyst pipeline on the GPU. For example, let's check the runtime. Yep, looks like we have a hardware accelerator. Everything is done in Colab, so I think we can share the presentation to check this notebook also. So what we have to do here, first of all, of course, we need to install the Catalyst. Moreover, for this tutorial, we also need to install a sub-package for machine learning with additional requirements for scalard, multiple bleed, and other packages, but not the case. So we have to install the Catalyst, and let's try our first demo with for loop wrapper. As far as I said, Catalyst is a high-level framework with all these low-level configurations, so you could easily transfer code from the PyTorch to Catalyst. What we have to do here, first of all, of course, import all required stuff and a few lines of code from the Catalyst. After that, we need to define our data, which is purely PyTorch primitives, and our model containing optimizer, once again, pure PyTorch, no additional primitives. After that, yes, we need to define our logic of our pipeline. So we need to define our custom runner, which honestly the main part of it is this handle batch method, which is once again pure PyTorch way. So we need to unpack our batch, run forward pass, compute loss, compute other metrics with once again Catalyst predefined metrics. Why not log these metrics, update our statistics for our metrics calls. For example, we have here a batch-based metrics, and at the end of the logger, we like to get loader-based metrics. And if it is a train loader, then we could run our backward pass. Everything is done with PyTorch, so no additional experience required, we can say so. After that, we should create our abstraction for the model logic, and pass all our components to the train method. Quite straightforward. For example, model, optimizer, loaders. We could also specify a logging directory for checkpoint saving and also logs. Our number of epochs, our flag for this fancy TQDM progress bar, and a few and set up our checkpoint selection, for our checkpointing. After that, we hit the run, we see the dataset loading, and a few lines with Catalyst logs with all these metrics per each loader. And in the end, we have a short report about best performing model on your validation. In this case, it was the last one with this, what we have defined with this, with these flaws. So this is the first introduction example in the Catalyst. Once again, as you can see, this is quite simple. It's just supervised learning tasks. So let's move to another one, a little bit simplified. So as I said, as far as this is only a typical supervised learning task, could we make additional abstraction to solve it quicker? Let's check. Once again, simple imports, the same one, by the way. Let's create our data, the same one. Let's define our components for the training, and let's use a supervised runner, which is a runner for the supervised learning tasks, and pass everything that we already know to the runner. But let's use our Catalyst callback ecosystem for some user-friendly features. For example, we could quickly compute the accuracy metric, the precision recall F1 score and support metrics. And moreover, we could easily plot our confusion matrix with the confusion matrix callback. After that, all what we need is just define the number of epochs once again, the logging directory, specify the checkpoint selection logic. By the way, what is important here is that thanks to the predefined by us metrics, we also could select computed metrics for the checkpointing. For example, in this case, we would use F1 score with meter averaging as our model selection metric. What is once again important is we could use F1 score with micro aggregation. So if we are speaking about different metrics, all Catalyst metrics supported different aggregations like macro, micro, and weighted aggregations, which is quite important if we are working with production-oriented deep learning. So we should maximize this F1 score, so we do not need to minimize it. Because of the matrix number, let's stop verbosing, but as far as we are working with a high-level framework, let's run our experiment with mixed precision training within one line. So what we have here, we have the same log with the same a bunch of metrics for each loader. By the way, there are a large number of them because we specify quite a lot. And once again, we have this macro, micro, and weighted averages. And what is even more important, we also have per class statistics for each this metric. Once again, if we are speaking about the production deep learning, it's quite important to have this full picture of your model. So everything else is the same. We have the top best performer model report in the end, and so on. But let's go to the, sorry for the speed up, but we have a limited time. Go to the third example. As I said, Catalyst also supports multi-stage pipelines natively within the framework. So let's check it out. As far as this is quite advanced stuff, let's define our custom runner with this internal Catalyst API. For example, what is interesting here, we have to define our hardware accelerator engine with this MP engine, which utilize PyTorch mixed precision training. We should define our quite default loggers for console logging, CSV logging, and TensorBolt logger. We should define our stages, which is really important because we would like to use 2 of them. Each of them should, I don't know, last 3 epochs. Why not? With the same data, but what is important here, with quite different models. For example, we have a 2-layer network, for example, and during the freeze stage, we would like to block the gradients on the head. And during the second stage, unfreeze, we'd like to tune the network tune the whole network. Okay. And after that, we define the criterion and optimizer. Once again, as far as we have an ability to define the coordinates per each stage independently, we could use this ability to set up Adam optimizer at the first stage of our experiment and stochastic gradient descent optimizer for the second stage of our experiment, which is quite common practice if we're speaking about the freight tuning. After that, we specify our callbacks, already known, with metrics and checkpoint selection. By the way, which is interesting here is that we could easily define the number of top best performing models which we would like to save. And our, once again, handle batch logic, which is quite straightforward. It does typical supervised learning tasks, but let's give it a try. We create this abstraction and hit the run. In the end, we have this already typical log with I don't know, all the metrics from the first stage and top burst performance report in the end for the first stage. And after that, we natively continue our training to get this second stage run natively with the same log structure. And in the end, we have this for best performance model once again. So what else do we have here is that all these examples are going with the TensorBolt support, which is natively integrated in the Catalyst. So if we have defined our logging directory, we all additionally turn on our TensorBolt logger, so we could check out all our required plotting curves during the training or after that. So what is important here, we have all our metrics specified. We have learning rate, also momentums for our optimizers, loss. But as I said, once again, for all these metrics, we have different aggregations like macro, micro, and weighted, and per class statistics. Once again, both per batch and per epoch. Okay, looks like something loading. Let's check it here. It's just simple accuracy, but still. By the way, you can see here an interesting thing that during our multi-stage pipeline, which is the last one, we have this jump in performance after the model unfreezing. So quite common thing, right? So it was all the first example, but I hope we have additional time to show you another one, because I still think it's quite a great one, because it introduces the TPU support of the Catalyst. So let's check it out. Once again, what we have here, our quite typical requirements. You have to install Catalyst, you have to install Google Cloud TPU client, and for this setup, let's also check how we could integrate Hugging Face datasets and transformer within the Catalyst framework. So what we have here, just to check up. By the way, let's check that we have TPU integrated. Yes, we have TPU. Yeah, after all this installation, we could easily check the versions, and if we have if we could set up XLA correctly, looks like yes. And here it comes, our second advanced example during this, I don't know, morning or evening. So what we have here, once again, typical imports from the torch, a few imports from the transformers, and a few from the Catalyst, and then we go to our custom runner specification to define all the logic of our pipeline. The main thing which is important here is engine definition, which setups our hardware accelerator. For this example, we use distributed XLI engine, which utilizes all 8 cores from the TPU. Moreover, you could also define just XLA engine to utilize only single core of the TPU, but what should we do here? Let's utilize all of them with the typical loggers, one stage only with 15 epochs, and I don't know, simple data from the transformers dataset for the classification part. So what we also have here, our model is just, let's use simple Albert, and with cross entropy loss, standard optimizer, but a little bit tricky scheduler, which works with the batches. So maybe for other frameworks, it could be some tricky part, but thanks to the Catalyst and its callbacks mechanism, we could easily define the logic how to work with this scheduler within this scheduler callback, and specify that we need to run this scheduler in the batch mode. That's directly all. All other callbacks are quite the same. For example, only accuracy, because I'm not sure what other metrics could we use here. Checkpoint callback for model saving and selection. Quite easy batch handling, thanks to the transformers API. And after that, all we need to do is create this abstraction and hit the run. In the end, we have quite a lot of logs from the transformers and datasets. Yes. And in the end, we have this already typical Catalyst logs with the loader-based metrics, as you can see here, and a model levels in the end. And once again, we have integration with the TensorBoard, so you could easily check all the plots, all the metrics with the TensorBoard, or other, I don't know, monitoring systems which you're fond of. So, generally speaking, it was all the examples. So let's move on. There are only 2 slides left. So what do we have here? Yeah. So I understand that it was quite a straightforward presentation. So if you are interested in more examples, please follow our minimal examples or just minimal examples README or Catalyst examples folder, where you can find some additional materials for example, model distillation for generative adversarial networks training or something else. We also have self-supervised learning pipelines and object detection one. So, nevertheless, let's move on. Before the last slide, I would like to say a few words about the idea behind the Catalyst. By the way, it's the eldest slide of the presentation. As I said in the beginning, Catalyst is a framework for both deep learning and reinforcement learning, which tries to help in sequential decision-making understanding through the expertise gaining in representation learning, recommender systems, time series, and reinforcement learning, of course. So if you are also wondering why these 2 domains are not the same, please drop me a message after the call. I will be glad to talk. And generally, here we go. Here we are. Thanks all of you for your attention. That's all. Now I'm ready to answer questions. All important contacts are on the slide, free to use. So thanks, all of you. Maybe I could still share the screen because.
Yeah, we'll keep this one on. There's a lot of good information on here, and I think we'll actually probably reference it in some of the questions coming up. Yeah. So thanks again, Sergey, for that presentation. For those of you who have kind of joined in a little bit later, so Sergey just presented about the project Catalyst that he's working on. So yeah, quick summary. It's a high-level PyTorch framework for deep learning and reinforcement learning. So it kind of allows an abstraction layer that allows you to build out. Still use the underlying PyTorch code, but in a simpler, more compact way. So with that, let's jump into some questions. So starting with PyPony up at the very top. So they're asking about, can you tell me where to start learning deep learning and practice this for free? And you definitely talked about that in your presentation.
Sorry, but I'm not sure that I'm really fond of our course, but I would like to mention that this is advanced course. It was created for the advanced purposes because we like to try implement all this fancy material which was developed in the deep learning for recent 3 years with the Catalyst framework. But if you only start your deep learning and would like to practice, I think that the PyTorch examples are really great. And mostly, I think that starting my career, I was starting with these Stanford classes with, honestly speaking, NumPy-based neural networks. And only after that, I moved to another frameworks and to very high-level frameworks. So, in my opinion, you should start from the basics. Really, it would be great introduction if you will try to write a NumPy network fully with your code, with your hands, with your mind, to understand how it is going on, how the gradients are computed, and all this stuff. After that, yes, you could move to the PyTorch, and maybe after a few projects, yes, you could try the Catalyst or I don't know, some other advanced stuff. But honestly speaking, I do not think that you really need high-level frameworks from the beginning. It's, from my experience, it's very bad practice. Sorry about that. But start from the basics. PyTorch is great for these kind of things.
Mm-hmm. No, I think that's a great, honest answer about it. And also kind of that differentiation between learning the fundamentals of deep learning and then learning a framework that uses it are different things. So
I'm very fond of the catalyst. Trust me, I'm writing, but there are a lot of layers of abstractions, and if you try to just go on top of it, it's hard to understand.
It's like learning to run before you walk. So make sure you get that fundamental down first.
It's like training BERT models before understanding CFDF.
Okay, nice. That should be a meme. That's good. Cool, thanks. Good question, Pyphony. Oh, it is a meme. I should up my meme game. So we have another question coming in about the Alchemy project. So maybe you could elaborate a bit about the kind of Catalyst ecosystem and where Alchemy falls into that.
Yeah, we also have a library named Alchemy, which was focused on monitoring. What happens? This is an open source, so sometimes we do not have enough resources to support all these frameworks, all these projects. So Alchemy is currently on the hold. So we have an ideas to renew it, but not today. Maybe next year, but sorry, not today.
Okay, well, thank you again for asking, and also just being aware that it's out there, and so maybe just keep a pulse, see what the team decides later down the road. Good question. So next one from Kadir on Facebook says, could you log metrics to different experiment tracking tools? I think you kind of had a slide that had some options.
Yes, it's quite easy. By the way, you could even log your metrics to different monitoring tools simultaneously. For example, if you are using, I don't know, TensorBolt, MLflow, 1DB, Neptune, Comet, you really could log all your metrics to all these monitoring systems for some kind of pure reproducibility, maybe. But by the way, you could log not only metrics, but your artifacts, your code, your images, because Catalyst Loggers abstractions is developed to support all this, to support everything you would like to log. So, yeah.
Oh, so robust. Is there a place that, if someone's interested, they could go learn about this? I'm assuming it's in the documentation.
Yeah, honestly speaking, the best place to start would be just hit catalystteam.com and then go to our documentation. We have quite a lot of materials about how to use our loggers and how they are about the whole abstraction. About how you could implement your own logger if you'd like. Sometimes you need it. Why not? For example, you have some custom logging monitoring system, for example, like Alchemy, which we're developing. Why not? Yep.
Makes sense. Let's see. So Kadir has another question asking, how does this framework compare to PyTorch Lightning? So that's a boilerplate version of PyTorch. There kind of differences between the two.
Yeah, I'm a little bit familiar with William. So, honestly speaking, it's a very interesting question. So, long story short, Catalyst is a fully open source project. So, for example, we do not have, I don't know, several millions of dollars from our investors. So we do not have a sales team, a marketing team, and all our teams to, I don't know, make marketing correctly. That's why you could heard about PyTorch Lightning quite a lot. Speaking of their design and the features, I think that Catalyst has maybe the same amount of features. And speaking of the config API, I think Catalyst is the only framework which supports config API natively, which supports Optuna, hyperparameter search natively within one framework, which supports multi-stage pipelines natively once again, because it was the focus on the Catalyst during the development. Moreover, I think that because Catalyst is developed by quite a small team, it's much simpler. Yeah, it's quite strange, but from the architecture point of view, it's quite simple to understand the Catalyst. We have only 5 abstractions, maybe 4. That's all. And on these abstractions, we build all our primitives, all our components. If you're speaking about another frameworks, high-level frameworks, for example, Lightning, for example, PyTorch Ignite, and all other, I think I'm really fond of the PyTorch Ignite. It's a really interesting project. It's with its own architecture view, but from my point of view, it's a little bit too functional. So I couldn't understand it. Sorry about that. But the implementation is really good and great. So PyTorch Ignite is a very interesting framework for inspiration. Overall, speaking about the Lightning, I found its architecture quite complicated to understand, because the amount of code and the amount of pivots in the architecture for, I don't know, for 1 year, there was too many pivots. So from the architecture point of view, I'm just not, Lightning is not my favorite, so sorry about that. That's why we are developing Catalyst as a much simpler approach. And with the Catalyst abstract, by the way, yeah, while I was talking about the frameworks, one really important feature for me is that all Catalyst primitives are mostly PyTorch independent. And we do not rewrite any PyTorch internals. We do not create any PyTorch model, custom PyTorch model, etc., etc. Because from architecture point of view is not the best scenario. It's all opinions are my own. That's why I'm not very fond of this architecture. Yeah.
Okay. No, I think that's actually a really interesting question, because yeah, we have, obviously there's this question, this problem that different teams are trying to solve in different ways, and I think that speaks to just different approaches to it. Yeah, and
yeah,
it's like,
we have quite a small team of the open source contributors, so we are not very familiar with marketing. Nevertheless, if you are interested in, you could easily go to our Slack, ask our questions, go for our course, go for our other packages. So from the open source community way, we are developing quite a lot, I think. Yeah, so if you are interested in, if you would like to join our team, our region, our community, we are open. We will be happy to see you there. So we do not have a sales team and marketing team to spread our words as fast as other teams could do it. Sorry. Yeah.
No worries. Yeah, I think to that point, Sarura on YouTube mentioned, like you mentioned about Ignite and this Catalyst. Yeah, it'd just be interesting. Maybe like in a future episode, we could bring
compare free frameworks.
Yeah, exactly. Just have you guys all come on and kind of have a discussion about.
Fight.
Yeah, I think the audience might enjoy that, because there's often just choices when you're picking different frameworks. So just to hear like, hey, what are exactly the pros and cons straight from the creators' mouths. So that could be an interesting discussion. Yeah, I don't know if you have
maybe.
anything to add to that before we move on.
Yeah, so speaking of the Ignite, by the way, I'm really fond of the Ignite guys. I know them. It's great. It's low level. It's developed in the functional way, but once again, it's my opinion. Because of this low level and functional design, I could not understand what is the difference with the PyTorch. Sorry, but PyTorch is low level, is easy to understand, and also from my position, quite functional way based. So with this PyTorch Ignite, yes, I understand that I could do quite a lot of things, but I don't feel this. I don't feel the high level speed up from the high level framework. That's why we have the catalyst, which tries to, yeah, maybe we can say that if you have, for example, PyTorch here and some complexity, then we could go to the PyTorch Ignite. It's a little bit more complex, and the delta is quite small, I think. Then I think we have the Catalyst project, the Catalyst framework, because it's somewhere in the middle. And in the end, we have this complicated lightning abstractions, which from my point of view looks like I don't know, maybe Java vision for the framework. I don't know. While the Ignite is still the most PyTorch based.
I see.
I try to develop Catalyst somewhere in the middle because I understand that yes, we need an abstractions for the high-level API, for simple API, for simple use cases, but we do not need any abstractions which rewrite PyTorch. For example, dataset abstraction, build abstraction, etc., etc. It's too heavy to understand, and you need to learn another framework, which from my point of view is a little bit strange. Yeah.
I mean, I think that makes sense in terms of your thought process on on that spectrum of how to design it. So that's interesting to hear that comparison. Well, it sounds like you've convinced someone in our audience to be interested in your team. Yeah, maybe can you talk about how, if there are opportunities for folks who are interested, like what's the best way to get involved, either as a team member or like you're mentioning projects that you're working on?
So how to join the team? I don't know. It's from my point of view, it's quite easy. We have a Slack. You could write in the Slack. You could write me directly in the Slack and ask a question. Usually we have a large variety of to-dos because once again, we are open source community. We do not have a large investment from the companies. So all our work is done by our motivation, our vision, our idea. So if you're interested in such stuff, you can just write in the Slack, write on this email. We will answer. The tricky part is that once again we are fully open source team, so we try to develop things. We understand that we have a life also, so sometimes we are developing them a little bit longer than expected, but still, as far as you can see, we have all this framework with all these integrations, with all this, I don't know, maybe complexity, maybe not complexity, with all these examples. So from my point of view, it's just the question of your motivation and interest. If you're interested in developing, in working your free time for some great, interesting things, you could just write us, and we can work together on maybe on your projects, because we are also interested in spread the word of the Catalyst, because we are interested in different areas. Once again, you see we have a large expertise in different domains, and we like to continue gaining this expertise through the years. Yeah. So I think, long story short, just write us and we will answer. Yeah.
Nice. Yeah, it sounds like a very open environment. So, like you said, it's built by people who are passionate about the project, about the cause. So, sounds like it's open to feedback from the community. Yeah, so great questions. I know we are kind of running towards the end of time, so maybe to wrap it up, I'll ask the question that we usually ask towards the end of the conversation, kind of a more existential question. But what about like deep learning in general, or PyTorch specifically, excites you in the next coming years?
Okay. I see a lot of opportunities in next coming years. For example, starting from something in the end, I think that current generative adversarial network progress is quite amazing. I hope every one of you saw this, a lot of generated images and all the stuff. Nevertheless, I am fond of the sequential decision-making problem and everything that is included something sequential. So I think, for example, in the computer vision domain, in recent 5 years, I hope we will see these networks for video generation, because it's much harder problem. And also, which I'm really fond of, it's the synergy between the deep learning and reinforcement learning. Yeah, once again, I think that the community, the researchers, should understand that generally it's just one domain. And for example, offline reinforcement learning is trying to prove this claim. So I think that in recent years we should see the growth of the reinforcement learning applications, for example, once again, for recommender systems and so on and so forth. And what is important, I think that we will see an online reinforcement learning application. I mean that could natively adapt for your experience, for your preferences, and training simultaneously with the inference. If you're interested in such a topic, you could see Siderel work from Google, I hope, which was published by the way 1 year ago. Where they have developed this infrastructure for such applications. So I think we could see it. So mainly, I hope we will see a synergy of different domains, because nowadays I see a lot of the same architectures, the same methods, the same tricks, we can say so, in different domains like computer vision, natural language processing, recommender system. And I hope the community will understand that there are a lot of that there are no differences between them for the neural networks and from the task specific. So I hope we will see this synergy.
Yeah, that's actually really good. Yeah, that's a great point. I think in terms of like generalizing it, like in terms of learning things, when you kind of see the foundational similar building blocks, like collectively you can move faster, because you can kind of see how things are and you don't have to reinvent things.
And I'm really seeking in this sequential decision making problem solving, because I'm really fond of the opportunity to see the progress in the sequential domain, because from my opinion, once again, it's much harder than just one single point. Yeah,
Mm.
that's why I think reinforcement learning is the way we should try to develop, try to master.
Interesting. Great points. And for those who are interested, so we are coming towards the end of the time, but Sergey is always available at Twitter, and then as he says on Slack. So check him out at his Twitter handle at Cidator. Sorry if I'm mispronouncing.
Never mind.
Close enough. At his handle there. And yeah, with that, it was a real pleasure having you on. Really enjoyed getting to pick your brain and kind of understand how you're building out Catalyst, and also just your thoughts for in deep learning and beyond. So for those of you watching, thanks again for your time and for coming in and asking your questions. We always love hearing your live questions. If you don't mind, dropping a like, or dropping a like before you head out. It would just be great to hear if you're enjoying the content, enjoying the guests coming on. And even if you have ideas like Sora had mentioned for potential new content, like a roundtable discussion with different projects, feel free to drop that in if you're watching it live or watching it later on. So we'll wrap it up for today, and see you all next week.
Thank you, guys.
All right.
Bye-bye.
Bye, everyone.